You may have learned how to figure out sine, cosine, and tangent using triangles, right triangles to be specific, and now we're going to learn how to find sine, cosine, and tangent using a unit circle. So a unit circle is a circle whose radius is 1. All right, so let's say that I was interested in getting the sine, cosine, and tangent of this angle theta right here. Okay, so I can drop down a perpendicular from this point on the circle, which we'll call x comma y, which means that this distance out to here is x, this distance up to here is y, and we've just created a right triangle. So that means that the cosine of angle theta on a unit circle is the adjacent side, in this case x, over the hypotenuse, which is 1, so cosine is x. And the sine of the angle theta is the opposite side over the hypotenuse, which is y over 1, which is y. And the tangent of the angle theta is the opposite side over the adjacent side, which is y over x. So if you know the coordinates of the point on your unit circle, you can get cosine, sine, and tangent by just looking at the x and y coordinates. So here they are summarized. The sine of angle theta is y, the cosine of angle theta is x, and the tangent of angle theta is y over x. And these are three other trig functions. Cosecant, it's written C-O-S-E-C-A-N-T. The cosecant of theta is defined to be the reciprocal of sine, so it's 1 over y. And then the secant of theta, S-E-C-A-N-T, the secant of theta is the reciprocal of cosine, so it's 1 over x. And the cotangent of theta is the reciprocal of tangent, so it's x over y. So these are the 6 trig functions. Now here's a unit circle with our special angles indicated, and we have x and y coordinates at each special angle. Okay, so remember that your cosine is going to be an x coordinate and your sine is going to be the y coordinate. So for example, the sine of pi over 6 is equal to 1/2 because that is the y coordinate at pi over 6. The cosine of pi over 4 is root 2 over 2 because that's the x coordinate of pi over 4. And the tangent of 0 is 0 because 0 over 1 is 0. Okay, so let's do some more examples. Find the sine of pi over 4. Oh, sorry, sine of 7 pi over 4. Okay, so we go back to our unit circle. We look up 7 pi over 4. There it is. Sine is the y value, which is negative root 2 over 2. So our answer for that is negative root 2 over 2. What's the cosine of 5 pi over 6? Okay, here's 5 pi over 6. Cosine is our x coordinate, negative 3, root 3 over 2. And the tangent of 3 pi over 2, okay, here's tangent of 3 pi over 2 is going to be the y over the x. Now we cannot divide by 0, so we say that the value of tangent at 3 pi over 2 is undefined. Sine is an odd function, so that means that the sine of a negative theta is equal to the negative of the sine of positive theta. Cosine is an even function, so that means the cosine of a negative theta is equal to the positive cosine of positive theta. So if we know those two rules, then we can evaluate sine and cosine of negative angles. So the cosine of negative 5 pi over 6 is the same as the cosine of positive 5 pi over 6. And we'll go up to our unit circle and look up 5 pi over 6, and there it is, negative root 3 over 2. Negative root 3 over 2. All right, now the sine of negative 5 pi over 3 is going to be equal to the negative sine of positive 5 pi over 3. So I'm going to go to positive 5 pi over 3, which is right here. I'm looking for sine, so I take the y value, and it's also negative root 3 over 2. And that's how you find sine, cosine, and tangent on a unit circle.